Okay, so here we are looking at the digestion of carbohydrates. We're going to follow these carbohydrates through the path of the digestive system, talk about both the mechanical breakdown and the chemical digestion that's occurring along the way, and we'll finish by looking at absorption and where those molecules go upon absorption. So we're going to start out here by grabbing these carbohydrates and we'll pop them into the mouth. And so we're going to notice that in the mouth we've got a couple different things going on. First of all, let's go ahead and list some mechanical breakdown that's going on in the mouth for these carbohydrates, but it could be of any molecule. So, of course, we've got mastication, where the teeth are breaking up the pieces of food into smaller pieces, and the tongue is going to be really helpful with that. Finally, the addition of saliva, the water in the saliva, is actually a pretty good component of assisting in mechanical breakdown. So we're going to get those pieces of food separated from each other. All right, in addition to this mechanical breakdown, we're also going to have some chemical digestion going on here, and that is due to the enzyme added in the saliva called salivary amylase. And we know that salivary amylase is going to be able to get after about 5% of the bonds. So I'm going to go ahead and grab my eraser here, and we will get rid of a few bonds here. So we're going to break down this little, well, maybe. Let's see if I can get my eraser to work. Break down this little bond here, and we'll break down this one here. It's probably a little more than 5%. But now we've got some smaller pieces, but we still have quite a ways to go. All right, so now let's move into the esophagus with these molecules that are just partially broken down. And we know in the esophagus there's nothing really more that happens with digestion. We're just going to be moving things along with the esophagus, a bunch of peristalsis to get those molecules down to their next step, which is the stomach. All right, in the stomach we are going to have some more mechanical breakdown going on. So we'll write that in here. We'll get a bunch of chopping actions by that oblique layer of the muscularis externa. Notably, there's no more chemical digestion, I'll put a big 0 here, of carbohydrates in the stomach. So let's move our carbs down to the small intestine. They're much larger than they should be, aren't they? Okay, so we've got our carbs here in the small intestine, and we are going to have to finish up the 95% of chemical digestion here in the small intestine. So we've got several different enzymes that are going to help with that process. First, we'll deal with the enzymes that can work just generally in the lumen of the small intestine, and that's going to be pancreatic amylase. So this enzyme is coming in the pancreatic juice, being released through the hepatopancreatic sphincter into the duodenum of the small intestine. It's going to mix with all of that chyme that's coming in from the stomach, and that pancreatic amylase can begin chopping up more of those bonds. So we'll erase a few more bonds here. And now we have gotten most of our bonds broken, but some of those disaccharides are still together, and we're going to have one more component that we need to add in here, and those are the brush border enzymes. So brush border enzymes are exactly what they sound like. They're in the brush border of the villi. And so let's go ahead and grab those carbs, and we're going to zoom them in here. And so what I've done here is you can see that I've got a little section of small intestine that I've zoomed in on so that we can see the villi that we've got. The villi right here. All right, and so the brush border enzymes are in the edge of those villi, and those enzymes are breaking down the last bits, and so things like lactase and maltase are enzymes that are there chopping up the last few bonds. So we'll get those last few bonds erased here so that we're down to monosaccharides. Now that we're down to monosaccharides, those monosaccharides are capable of being absorbed by the brush border into those simple columnar cells, and the simple columnar cells will absorb them into themselves and then move them into the bloodstream. And then we've got all these little monosaccharides in the bloodstream that can travel via the hepatic portal system into the liver. The liver's got two jobs to do here. One of them is that, and if any of those monosaccharides are not glucose molecules, the liver will quickly convert them into glucose. It's a really simple procedure, so that by this time, instead of saying we've got a pile of various monosaccharides, we will have a pile of glucose molecules. One other thing that the liver may do upon the influence of insulin is grab some of those monosaccharides and build them back into short-term energy storage molecule called glycogen. So that's one possibility for where those glucose molecules will go. The other possibility where many of those glucose molecules are going to go is into the bloodstream that goes to the rest of the body. And the purpose of all of those glucose molecules in the bloodstream to the rest of the body is to supply all of those cells with some sort of food molecule for cellular respiration. And that is the story of the digestion of carbohydrates.